Well, good afternoon, everybody. My name is Andrew Braham, and welcome to our Pavinar session today. Today's topic will be Hot-in-Place Recycling 101. If you can't hear me talking right now, please check your computer volume and or your speakers. If those are fully functional, you can go into the Illuminate software, and if you go to the Tools menu, down to Audio, Audio Setup Wizard, and then you can follow the instructions for help from there. Now during the Pavinar, if you have any questions, I encourage you to raise your electronic hand, and that can be located on the left side of the screen underneath the list of participants. It's a little blue hand with a green arrow, and if you click on that hand, your hand will raise on the participant list. And I can see that you do have a question. And I will either pause at that time or at a convenient break, and then you can type your question into the chat box. So beneath the participant list, there's the chat box that you can see, and then below that chat box you can type in questions, and when you hit the send button, everyone will be able to see that question. After the Pavinar, Professional Development Hour certificate will be emailed to you. Now, actually the next couple days are quite chaotic for me, so you will probably get these on Friday. But be rest assured they will come later this week, and if you do not get them by Friday, please email me and I will make sure that you get them. So the topic today will be hot-in-place recycling, just some background, overall basics, and some general concepts of the technology. So I'll talk about what is hot-in-place recycling, and then a little bit of history. I found a very nice presentation online that has some pretty cool pictures, so I was excited about that. We'll talk about in the laboratory what you need to do with the mix design, and then also go over an example of one Kansas's DOT's performance testing that they do with their hot-in-place recycling. That's just one example, but they're pretty innovative in that area, so we'll go over an example of that. Then we'll go into the field. We'll go over some special equipment needs and also the construction process of hot-in-place recycling. Then we'll see some example projects, what are typical candidates, kind of what are some of the surface distresses that you can see, and then also have some data for HIR costs and then the construction rates, how many miles per day can you put down, and things like that. Now this will be a very broad overview of each topic. If you want more details in any of these areas, I do encourage you to submit a topic online under the Submit Topic tab on the Pavinar webpage. So what is hot-in-place recycling? Well, it is a pavement rehabilitation technique. It is relatively low cost, and one of the reasons for that is it uses a lot of in-place material, and that saves costs for shipping aggregate or shipping hot mix, shipping concrete, shipping material from some off-site source to the job site. And it can correct surface defects, so a cracking, mild rutting, mild shoving, those types of surface defects, but it does not solve structural problems. So if you have a roadway structure that has load deficiencies, the loads have increased, either the number of vehicles or the weight of vehicles, if they have significantly increased, chances are hot-in-place recycling would not be able to aid with those type of distresses. But any type of surface defects it can handle. And these are things such as the cracking, whether they be low temperature, longitudinal, transverse, some mild rutting if you have holes, shoving or raveling, and then also other small bumps that may be occurring. But again, all of these are surface defects and they don't influence the actual structure of the pavement. So when you look out at literature and you look out at different types of HIR techniques, there's actually quite a range of HIR techniques and processes. So what I'm going to do is kind of go over a broad example of what the 4 general steps are, and then I'll get a little bit into each of the different processes, but not go too in-depth, just kind of scratch along the surface, to use a little HIR metaphor, if you will. Scratch along the surface of of the techniques themselves. So the first thing you need to do is you need to soften the pavement surface with heat. And on the pictures on the right, you can see those 4 large yellow machines in the foreground. And what those are doing is physically heating the pavement surface. And once you've heated it, you somehow mechanically remove that heated surface material. And you can do that either by scarifying the surface, which we'll see in a couple of slides, or you can actually use a mill of sorts and mill that material up. But the benefit is that it is at a higher temperature, so then you can add things like recycling agents or even a little bit of virgin aggregate, asphalt binder, or asphalt emulsion. And because that aggregate and the in-place asphalt concrete is heated, you see some blending of the in-place materials binder and then whatever additives you're adding to that, which would be the third step. And after you have added those either recycling agents, virgin aggregate, asphalt binder, or asphalt emulsion, you can lay down the mix behind, in the picture on the lower right, you just see a typical paver that you'd see on any hot mix job. And then you need to compact that with a roller. So those are the 4 general steps in any HIR process. So the kind of the fundamental behavior behind these processes is you want to make sure you reheat the material gently. If you Google HIR and then look at for images, you'll see some with flames literally coming out from underneath the heaters. And if you have unqualified crew or inappropriate equipment, that is a possibility, but you don't want to go there because then you just end up burning your asphalt, which degrades it even further. So you want to gently reheat it in order to rejuvenate that asphalt binder at that upper layers. And when you do reheat that, then you want to loosen the material. And like I said, you can either scarify it, which is in the picture below. Literally, there's little hinges down there that are scraping the pavement and kind of mixing the very, very top layer there, getting that very highly oxidized, very thin layer on top mixed in with the unoxidized layers anywhere from 1 to 2 to even 3 inches below there. Mix that up a little bit. Then you can remix the heated material with some sort of additives, as I mentioned on the last slide. You can put in rejuvenating agents, you can put in asphalt binder, you can put in asphalt emulsion. There's a lot of different options there. And then you simply lay it down with a screed and you compact it. And what this does is you eliminate surface distresses. You do not increase the structural capacity, and you cannot solve structural problems with your pavement, but you can correct surface distresses. So this is some of the pictures that I found from a very nice presentation put together by John Emery in 2009 for our ARRA conference. And this was one of the first HIR jobs, and this was held place in Toronto, Canada in 1916. And they used a steam power heater. You can already see kind of the methodology being applied. You have a big heating unit on the right there, which is heating up the pavement, which had been laid sometime in the past and is now being reheated. In 1936, this was an unknown location, but again, you have a tractor with some sort of heating unit behind here, and this is kind of an example of what you don't want to see on an HIR job, because they are literally burning the asphalt concrete at the very top, and that doesn't allow you to get those rejuvenation properties out of the heated wrap. All it does is burn the wrap, and then you're left with more of an aggregate versus a wrap with some activated binder on the surface, which loses one of the key benefits of HIR. And you can see the equipment progressing here. This is another unknown location, but in the 1970s, there's a heating unit in front of what looks like to be a slightly older screed. So they're heating the unit, or they're heating the material, then they're remixing it a little bit right in front of the screed and then placing it back down. And you can see right here they're using approximately 1 inch of thickness being heated. They scarify it, they added some rejuvenation agent, mixed it, leveled it, reprofiled it, and then compacted it. So these are kind of these basic steps that I talked about earlier in hot in place recycling, all mixed into one, at about 1 inch thickness. And then in Vancouver in 1988, you can see that the equipment's getting a little more sophisticated. It's certainly getting larger, but now we're able to go 1 to 2 inches thick in heating that surface. So the heaters are becoming more effective of getting the depth that really brings out some of the benefits of HIR. And after you heat that 1 to 2 inches, again, you scarify it. You can put rejuvenating agent in there, asphalt cement, asphalt emulsion, those type of things. You mix it, level it, reprofile, and compact it. And around this time in the mid-80s, they also started putting surface treatments on top. So for this example, they put an HMA overlay, but that now has been extended to chip seals, slurry seals, ultra-thin bonded overlays, and even something as simple as a fog seal. But just a little additional binder or additional surface course on there in order to get some traction and to aid with the rehabilitation of the pavement. And then finally here in 2001, we're in the next generation, or the most current generation of heaters. The heaters are a lot more sophisticated. Up to 3 inches of thickness of your pavement structure can be heated, and you can either scarify it or you can mill it up, rejuvenate it, you mix it, level it, reprofile, place with the paver, and compact it. So over the past 10 to 20 years, we've really seen an increase in depth that we're able to heat it. And again, the benefit of that increased depth is you're able to bring that material that's lower in the pavement structure, that has less oxidation and that has more of those binder characteristics you're looking for. You can bring those and mix them with the upper layers, which are more oxidized and have less of the characteristics you're looking for. And then overall, your pavement surface will be a much higher quality. So that is a little bit of background, a little bit of what is HIR, and then an example of how HIR has developed over the past 100 years, according to that first slide in Toronto. And now we're going to go into the lab portion. But at this point, I'll take any questions. So again, if you look at the participant box, right below the participant box, there's a little electronic hand. If you have a question, please raise that electronic hand by clicking on it, and then you can type the question into the chat box and hit the send. And we do have a question, and the benefit of the electronic hand is that makes me know that someone is typing, which gives us a little time to wait for the question. So the question is, what kind of life can we expect? And this is a very good question, and I'm going to hold off on it if we can, because as we kind of move through more of the presentation, we might start touching on that. But as we move through, I'll make sure to continue or to highlight it when we do address it, but that will come later in the presentation. But thank you for the question. Are there any other questions at this point? All right, so moving into the lab portion of hot and place recycling, there is no established mixed design procedure available. So if you go out and you look at different state agencies and what they're doing, if you're looking at different contractors who have done HIR, there is really no commonly accepted HIR mixed design procedure. But when you start looking at more and more of them, you will see that there are 4 general steps in the mixed design procedures that are out there. The first thing you need to do is to determine the material properties and proportions. So you have to go out into the field, determine what's in place. You need to determine how deep you're going down into your pavement structure. Can you only go 1 inch down? Do you want to try and go that full 3 inches that we're now able to do? So you have to figure out what kind of materials you have in place and what are their proportions. Then you need to prepare your materials for a mixed design. You need to take them out of the field into the lab, and then you need to break them down into testable sizes in a method similar that you would see in the field, so you're able to do step 3, which is completing the mixed design itself. And then when you're done with the mix design, you can carry out your quality control or your quality assurance tests. So the first step is you need to determine your material properties and their proportions. So you want to first represent or obtain a representative sample of RAP, or recycled asphalt pavement. If you're going to be adding new aggregates, you need to put those in as well. And then also if you're adding asphalt cement or asphalt emulsion, some sort of binding agent or a recycling agent, or a rejuvenating agent, you also need to obtain samples of all of those. So you have all the basic materials that you're going to be using in the field in your lab. Now, depending on which state you're in or what kind of test your agency requires, there's a wide range of asphalt cement tests that are out there. And they go anywhere from simple asphalt cement content to running penetration tests on the residual or the extracted binders, viscosity tests on the extracted binders, or super pave tests. So you take the RAP that you have, you recover some binder from there, you mix it with any new material you're going to be using, and you can classify it either using a penetration system, a viscosity system, or a super pave system. So there's really a lot of options, and you can really do whatever your local agency or whoever the owner of the job requests. You need to determine the gradation and the bulk specific gravity of the RAP aggregate. And this is a little bit difficult because you'll notice that after heating the aggregates, or heating the in-place material, you can either scarify the material or you will mill the material. So this is a problem that's very similar to cold in-place recycling, is that you need to simulate as best as you can how the material will act in the field, but simulate that in the lab. So whether you crush the aggregate, which would be a little more representative of the milling, or you heat it and bust it apart with a spoon. The important thing that you need to do is try and simulate what you're doing in the field and simulate that in the laboratory so that the existing asphalt concrete behaves in a method that's similar. And I personally believe that this is one of the reasons why there is no established mixed design procedure for HIR, is because this question of how do you take the cores that you bring into the lab and then transform them into the material that will actually occur in the field. But being able to do that in the lab is a very difficult step. So you do want to try and simulate the gradation as best as possible. You also want to figure out your bulk specific gravity, your percent crushed aggregate with that RAP. If you're doing some milling, you might be doing some crushing, but you want to know what you have in place, and also the absorption. And this goes for both all of the existing in-place material and then also any new aggregates that you bring into place. And then once you've kind of done all of those material characterization tests on both the RAP, the asphalt cement, and the virgin aggregates, if you're going to ask, you want to make sure you can adjust gradation if there's any sort of specification compliances that you need to worry about. You want to test for VMA, and then you can also do some performance testing. Then, you need to prepare your materials for mixed design. So you want to determine a range of total asphalt content required, and this can be based off an estimated asphalt content, or you can, this can be based off an estimated optimal asphalt content, and then you can select alternative asphalt contents both higher and lower than your estimated optimal asphalt content, much like a standard mix design. So after you've done that, you can select your recommended grade or preferred penetration, viscosity, and super pave grade of either your new or any sort of additional binder that you're adding. So if you're going to be using an emulsion, then you'll need to take the residue of that emulsion and figure out what grade you have there. And then you want to determine the mass of RAP you'll be using, any new aggregate you'll be using, and then the new binder for each asphalt content. So in a way, this is very similar to a traditional hot mix or now warm mix design. We're trying to look for these optimal asphalt contents, and we're trying to incorporate these materials that we're bringing in together. But now there may be some additional things that we're looking at. How do we obtain representative samples from the field? How do we break down those samples in the lab so they're representative of what's in the field? And then also we may be adding a rejuvenation agent or rejuvenating agent. Because one of the big things that we're trying to do is kind of rejuvenate this layer because of the heavy oxidation on the very surface. So that may require some special care. Once you have gotten all your materials together, you have all the proportioning correct, then you can complete your mix design. And basically what you do is you prepare compacted samples in the lab, incorporating your wrap, your new aggregates, and your new binder. And this binder may be traditional asphalt cement, it may be asphalt emulsion, and you can also have some rejuvenating agent in there as well. Then you need to test these samples that you made for your bulk specific gravity, maximum specific gravity, any sort of performance tests you want to run, air voids, voids in mineral aggregate, and also the appearance. You want to make sure that you're getting a good looking mix. That is one of the new things that is added on to the mix design. I'm not going to go too in depth here into the mix design because we want to kind of cover all facets, but there are kind of a couple of tweaks in here that you need to look out for. And then at the end of the day, you want to report your recommended recycled mixture design. Now, the question that was posed before, what kind of life can we expect? You can see that this is a pretty complicated question because there are so many variables here. And this is just in the mix design. One of the things you could do at this point is do a traditional hot mix design alongside of this, or even a CIR mix design if you have experience using cold in place recycling, but do a parallel mix design with something that you've already used and you have a little bit of knowledge of how it performs in the field, and then you can compare how this performs side by side in the laboratory, and that may give you an indication. There's no studies out there that say, you know, HIR will last longer than a traditional hot mix design or shorter than a traditional hot mix design, because there really are just so many variables. But this is one thing you could do, is run concurrent mix designs and compare them at the same time. And then you can see here at the bottom, you'll get these graphs that are very similar to traditional hot mix designs. You have your asphalt binder by weight on the x-axis, and that includes the wrap binder. It includes any sort of asphalt cement or asphalt emulsion binder that you add, and you also need to account for the liquid rejuvenating agent in there too if you're using that, because that'll help with the workability. But then you have on the y-axis your air voids, your percent VMA, percent bulk specific gravity, those types of things. And once you have completed the mix design and you have recommended what mix design to use in the field, once you get out there in the field, again, it's pretty similar to conventional hot mix asphalt or cold in place recycling, depending on kind of what angle you're going for. Because you're using in-place material, you do want to monitor what's going on with that wrap. If it had just rained, you may have some moisture problems. The heating does certainly evaporate a lot of that moisture, but it may not evaporate all of it. So you want to make sure you have a moisture content in line. What's happening with the gradation? If you go from one job to another, you may have slightly different mix designs. There may be a different day that was paved, which means the gradation may be a little bit different. And then also, what is the asphalt cement content? So all of these need to be monitored as you are going along the road. However, there is more emphasis on things like absolute viscosity, penetration, or the super paved asphalt cement characteristics of the recovered binder. And this is because at the end of the day, since you're using all this in-place material, you want to make sure that they properly bind together. And that's really driven by the asphalt binder that's in place. So by monitoring that, you are making sure that you are being able to get the binding characteristics you want, and you won't have any premature failures in the field. Now I'm going to briefly go over just one example of performance testing that DOT has implemented. You'll see there's a link there below. Unfortunately, links do not work in this software, in the Illuminate software, so if you try and click on that, it won't pop up in a new new internet window. But when I download the PDF file on the website, you'll be able to access and copy that link. But in the state of Kansas, which has been quite innovative with the HIR performance testing, they run 3 tests. First is the tensile strength of the retained strength, and they run their own specification for this, KT56, which is based on the AASHTO T283 specification, which is the moisture-induced damage specification. The second test they run is the AASHTO TP63, which is the APA, the reading from the asphalt pavement analyzer. And then the third performance test they run has to do with thermal cracking, and their specification is KT50, which is based on AASHTO TP9 or T322, depending on which specification you're using, which is a strength using the Superpave Indirect Tensile Test, or the IDT. So when Kansas went through their process, they felt that there were 3 key properties that they need to measure: the retained strength, the rut resistance, and then also the thermal cracking characteristics. Now your DOT might have a slightly different set of needs, but that's kind of the nice thing about developing these specifications, is you can kind of look at historically what sort of distresses have you had in your area, and then you can add performance tests or take away performance tests as needed. So that's just a brief overview of the lab. Overall, you saw that it was very similar to kind of a blend of traditional hot mix, asphalt mix designs, and then also a little bit of cold in place recycling mix designs, because you're dealing with this in place wrap, which you need to know the characterization of. But next we're going to go into some field notes, important things to see in the field. But at this point, are there any more questions, especially on the lab component? All right, there are no more questions at this time. So we'll move on to the field process. So there are 4 steps in the construction process for HIR. You need to heat the in-place road, then you need to either scarify or mill it, you need to rejuvenate it and mix it with the rejuvenating agent, and you can use rejuvenating agents, you can use asphalt cement, you can use asphalt emulsion, and then you need to replace it. So we're going to go over the equipment needs for each of these 4 steps. So the first thing you need to do is you need to heat the picture, and this is a picture of an AR20 unit, and there are usually 3 to 4 of these in front of your paving train, but there are certainly multiple heaters to make sure you get to those depths that you need. And now they use either radiant or infrared heating used. There's no longer direct flames used. That is because, you know, as you saw in the one picture back in the 30s, and that has happened more recently, the use of direct flames, you can literally light the road on fire. And that's not only bad for the pavement, it isn't good for the traveling public to see that either. And in order to power these heaters, you can use either propane or really any type of fuel to power the heating units. And the temperature of the pavement is raised to approximately 230 to 302 degrees Fahrenheit. So you can get a pretty high jump over the ambient temperatures of the pavement by using these heaters. And I have here, it can be performed anywhere from 3/4 of an inch to 2 inches deep, and I apologize, that can go down to 3 inches deep. I must have looked at an older reference when I was making this slide, but you can get down to 3 inches deep now with the technologies. After you have heated, here's a picture of scarifying the pavement. And what happens is there are multiple rows of spring-loaded scarifiers, and they literally slice through the pavement. So if you're cutting a cake with frosting on top, you drag that knife just across the surface and the frosting, and it scarifies that frosting. That's what we're doing with the pavement here. And they are spring-loaded, so you'll see in some application pictures upcoming, but manhole covers and utilities, these basically just bounce over those. So you're able to heat those utility covers and then just scarify around the utility covers. An alternate to scarifying is to actually mill that surface up. And the nice thing about milling that surface up is that you can really get some extra mixing in of either the asphalt emulsion, the rejuvenating agent, any virgin aggregate that you may have in there, or asphalt cement. You can get better mixing if you mill it up and then you can put it through a pug mill on that in the HIR train. And what this does is by milling it, you open up the heated material, and you can mill a 1/2 inch to 3 inches of material deep, up to 16 feet wide, and then the material is placed in a windrow after the behind the milling machine and before the paver. So if you recall, after heating, it was approximately 275 to 300 degrees Fahrenheit. And then after the scarifying or the milling, the temperature dropped pretty significantly down to between 200 and 275 degrees Fahrenheit. So still above ambient temperature, but after this milling, you lose quite a bit of your heat. While you are scarifying or milling, you can add either your rejuvenating agent, virgin aggregate, and also your asphalt cement or your asphalt emulsions. One of the dangers of adding asphalt cement is that if that temperature starts dropping too much, you can start having compaction problems. So that is why asphalt emulsion is a pretty popular alternative, because you still get that lubrication for the compaction, so you can get your density at the very last step. And you can also, and then once you've added all of those, you mix them together, and then you can either spread them across the lane. So if you're using scarification, they often just leave the material spread across the lane width, or if you're using a milling head, they often put it in a windrow so it can be collected easily. Now at this point, if you are, for example, using asphalt cement and you saw that temperature drop, you can do a second round of heating. That is an option that would require some more of those heating units on the job sites. But if you keep the material across the lane after, say, scarifying, usually they have an auger in place right in front of the laydown machine, and a screed cuts those edges and then provides that initial compacted. So the augered material does a little bit of mixing, then it's put through the screed, the edges are cut, and you can have that initial compaction. Now if you place it in a windrow, you need a pickup machine, and you can transfer the mix into a paver with the screed behind it. And something very important to note is if you're adding new aggregate, you want to make sure that you have a complete coating of that new aggregate. So it could be a little more risky to use the auger because you don't have quite as much mixing, whereas if you place it in a windrow, you can actually put those milled materials along with the new aggregate, and any of the additives, you can put that through a pug mill or something and then place it in the windrow. So there's kind of some pros and cons to each one of those. And then after it's been put through the screed, you just simply use a steel wheel roller to provide the finish, and you want to get it to whatever density you need. So again, that's a very brief overview of the field. But if you have any questions about the field of the lab, we can take those now, and if not, I'll move on. Okay, thank you, Danny. You got a question? Oh, the question is, how far can a typical operation get in one day? Well, that is actually the last slide we will cover, and I don't want to give away any information, but we will cover that on the last slide here at the end of the project session. But thank you for the question. And it looks like Judy has a question. Thank you. Oh, so the question is, if you have found you've used a substandard material, can it be fixed by this process, or do you need to start over? And that is an excellent, excellent question. And I was pretty excited to see some people from the Arkansas State Highway Transportation Department on here, because this exact example has happened on a couple stretches of interstate where there seems to be some flawed material in the surface layer, and they're looking at the potential of using HIR in order to see if we can remedy that. And I think I love being able to answer this way, but there are no there's no recommendations one way or the other. But I think what you would want to do is you would want to take samples from the field and then go through that mix design process and then focus on the performance testing, because that'll really differentiate if the material that's in place will be able to be utilized in a future HIR design. And if you get very poor performance test numbers, then I would say it may not be a good idea to use HIR in this case, and you may want to do a more traditional mill and fill, which is where you take material away that's bad and then you put new material in. But really there's no right or wrong answer there, but I think that during the mix design process it would be a good opportunity to see if the in-place materials are good enough quality. Thank you for that question. And then Danielle also has a question. So what ride quality can be achieved compared to a typical grind and overlay job? So this is kind of looking at behind that steel wheel compactor after you've compacted it, what kind of ride quality you have. What's your IRI look like? And I actually have not read anything specifically addressing this. However, just based on visual observation, and we'll see a couple of projects here and see that the HIR that was recently put down, I think that you can have just as good a ride quality off HIR jobs as you do a traditional hot mix job or warm mix job, just as long as you go through the mix design properly and then the construction properly. So just like bad construction techniques could give you poor ride quality on a HMA or a WMA job, I think the same thing could happen here with HIR. And there are a lot of experienced contractors out there, and there are probably some inexperienced contractors out there. So if you're thinking about using this, I would highly advise you to talk to maybe some other state agencies that have a little more experience with this and say, what are some of the key things that we need to really focus on when we're on that job site to make sure that you're going to get that proper ride quality. But I think just like HMA or WMA, as long as you do the proper mix design and you're doing proper construction techniques, you should have absolutely no problem with ride quality. You should see no drop. And then David asked the question, what is a typical range for air voids in HIR? And I think that is depending on what you want as the final air voids. Usually surface courses, you're aiming for that 96% density, 4% air voids. If you want a slightly tighter mix, you can design for that. Or if you want a slightly more open mix, you can also design for that by adding that virgin aggregate. But again, I think it's my perception that HIR should, at the end of the day, be identical to HMA or warm mix asphalt. You won't be able to tell any sort of ride quality difference, and then like these kind of end parameters like air voids and density, they really shouldn't change, because at the end of the day you want a typical asphalt concrete surface course in place. So I haven't seen any guidelines for typical ranges or any sort of recommendations to go outward, but going out on a little bit of a limb here, I would say it's just the same as what your typical hot mix or warm mix air voids would be. Well, thank you very much. Very good questions. We'll move on to the project, and then also at the end, if people would like, we can ask some questions there as well. So the next couple slides are just kind of an indication of what is a typical hot-in-place recycling candidate. And you obviously can't have like 4-inch deep ruts. You can't have a completely blown away or raveled surface. So this is just kind of getting us in the mindset of going out, looking at a road, what is a good typical HIR candidate. So you can see here this is a relatively highly oxidized road, and there is some mild cracking. In the right lane, the traveling lane, there seems to be a little bit more cracking, but in the left lane there's a little bit of left. But this is a 4-lane divided highway. This could be an interstate, it could be a state highway. But at the end of the day, there's a little bit of oxidation and there's some mild cracking, a good HIR candidate. This too, this looks like a 2-lane road. We got a yellow line down the middle, but there's a little bit of polishing, especially in the wheel paths or at some joints. There's obviously been some cracking and some sealing. This would be a good HIR candidate. We just have some mild surface distresses. It doesn't look like there's any structural problems, so this could be something that would be well served by HIR. And now this is in a residential setting. And you can see that in the foreground there is the existing pavement. In the background there is the rehabilitated pavement. And I don't know anything about this road in particular, but it kind of looks like this could have been an overlay. The cracking pattern looks like it's the square panels of Portland cement concrete, and it also looks like there may have been some decracking on that Portland cement concrete. So if you have a thick enough overlay on top of Portland cement concrete, you can use HIR to address some of these lighter cracking issues and the oxidation issues. Now, you do have to be careful, because if these cracks propagated through hot mix asphalt from the overlay, chances are the cracks will eventually propagate up through HIR. But this is just another solution to milling and filling, or just putting on some sort of thin surface treatment. Now, I put this one on not because we can look at the roadway and see what kind of existing distresses are on there, but I did just want to point out that HIR can be done during the night. Now, you want to be a little more careful with the pavement temperatures, because obviously you don't have the sun coming down on the pavement. Usually temperatures are a little cooler at night, but if properly managed, you can do HIR candidates at night work. So if you're looking at your higher volume roads, this is something that might be of interest, especially say like on interstates or in urban areas. You can go ahead and try using HIR on those. And then this is a picture of I-35 in Kansas. You can see a before in the foreground and then an after in the background. And you know, we got some cracking, some oxidizing. It looks like there's been some patching along here too. So the nice thing about using HIR is that you mix the material a little bit. So if there's some fat spots of asphalt, which you can see in the very front here, theoretically that will be mixed a little bit and dispersed, so your final product, which is in the background, has an even asphalt cement content. And then this is up north in Waukesha County in Wisconsin. Looks like a residential area. This pavement had quite a few significant distresses. Now you'll want to make sure that these are surface distresses and there's no structural problems underneath, but HIR has been successfully applied on the right-hand side there. So just kind of a summary, we've seen examples of interstate work, of divided highways, undivided highways, and also some residential streets. Obviously, you want a relatively straight path. You have these large heaters, so you don't want to be going around a whole bunch of turns, but there are quite a few applications here you can use for HIR. And then, excuse me, there's more examples here. I wanted to show this one in particular. It's up in Manistee, Michigan. I apologize if I mispronounced that. But you can see I wanted to put this in because you have the manhole right there in the middle. And they probably use that scarifying technique where they're on the spring. So as you scarify that pavement and drag it along the pavement, it'll dig into the pavement. But when it hit that manhole cover, the springs popped it up and it was simply able to go over that manhole cover, which is a pretty convenient option, especially in urban areas where there's quite a few utilities. So the final slide here of technical content is your cost and your rate of construction that you could do. And got to put this disclaimer here at the very beginning. The cost is highly dependent on the size and location of the job. Obviously, larger jobs, the cost will go down a little bit. A location of a job closer to the contractor or closer to where a lot of the equipment you're using is, that will drive down the cost. And it depends on wage rates and also if there's any sort of working hour restrictions. This takes quite a bit of mobilization to get all this equipment going, so it's often beneficial to have slightly longer windows. That allows you to get a little more mileage for your dollar. That being said, these are some typical ranges. you can be as low as $4.50 a square yard, or approximately $41 a ton to place, and it can get up to $5.75 a square yard, or about $53 a ton to place. So that's a relatively large range, and it's certainly more expensive than your typical surface treatments, but it's definitely a competitive alternative. And then in addition to this, a lot of places do opt to include some sort of surface course as well, such as a chip seal, micro or slurry seal, ultra-thin bonded wearing course, or even an HMA overlay. This is by no means required, but it is a potential additional cost to the costs I have listed in that second bullet there. And then moving on from the cost to the construction rates. The construction rates, again, it depends on any sort of restrictions in your equipment availability, but a typical rule of thumb is you can construct approximately 3 miles per day for a 2-inch depth up to 15 feet wide. So that gives you a little bit of idea for your production rates. Now, I've already said for both of these are general ranges, but there are a lot of variables. So kind of take these numbers with a grain of salt, but I just wanted to give you a ballpark figure to work with. So in summary, at the very end we'll leave room for questions, but I do realize that people have things to do, so I kind of want to go through some logistics, and if you want to stay on for questions, please feel free to do so. Your PDH hour certificate will be emailed to you after this presentation. It'll probably be emailed out on Friday, May 4th. I got a couple big things to do these next couple days, but we'll see if I can get it out before then. Also, by Friday, May 4th, I will post not only the Illuminate video here that's being recorded, but I will also post a PDF file of the presentation, so you'll be able to download the presentation and get information off there as well. And I'm very happy to say that being on an academic cycle, it's almost summertime here at the University of Arkansas, so I'm going to take a summertime sabbatical from Pavinars. And also, I know all of you are in the construction business, so you guys will probably be plenty busy for the next couple months. So the next Pavinar will be Tuesday, September 4th. I haven't nailed down all the topics yet, but I will send out an email sometime during the summer with the full schedule of topics, and I'll update the website. And also then about a week before September 4th, you'll be getting a reminder email. But I please do encourage you to submit topics that interest you. These Pavinars are for you, and I have a lot of fun putting them in together. I get a lot of information out of each topic, and it's either good review or good learning for myself as well. So if you have topics that interest you, please submit them, and we'll incorporate them into upcoming sessions. So we went kind of from the background to work in the lab, work in the field, and then also some example projects. And we've already got a couple questions. Thank you for that. And I will answer them as they come. So the first question from Daniel is, what are the conditions for a need to have a final course? And that's an excellent question. You saw a couple slides ago I said that although it is not required, some states opt to have a surface course. And I really think that that's kind of up to the agency or up to the owner as to what they want to do. For example, if this area has had historical friction problems, you might want to put a chip seal on top of there if that's able to be done. If you want to add a little bit of structural capacity, you would want to put maybe a 2-inch overlay on there or something that could help out with that. But again, I think this is one of the reasons why, this is another good example of a reason why I don't think there's any established mixed design or established construction procedures, because there are so many variables that are going on here. Unlike, say, for example, cold-in-place recycling, where you know you may have raveling problems and a surface course is almost required, those type of issues don't occur with hot-in-place recycling, because oftentimes you're adding in either an asphalt and emulsion or an asphalt cement, so you're able to kind of restore to a typical surface course. Now, if you feel that it may be a little dry, that may be an opportunity for slurry seal or microsurfacing if you want to keep the asphalt content a little lower in the surface itself. So I do apologize, Daniel, but there really are no right or wrong answers. I think there are just a lot of options. So if you're considering going in this route, I would recommend contacting maybe some states in your area or some contractors around you, see if they have used it, see what their experience has been, because it's not only material dependent, but it's also climate dependent. But thank you for that question. And then Mark has a question: is joint sealant bleed through an issue for thin depths? And that's also a very good question. You saw in some of these pictures, in fact here on the right, if you can imagine above the project session, if that has joint sealant in it and you only go maybe half the way down or 2/3 of the way down into that layer and there's joint sealant down there, I haven't read anything about it being an issue per se. But I think just like putting a typical hot mix asphalt or warm mix asphalt overlay on top of something like a joint sealant, I do think that is something that you need to be aware of. And I don't want to say that there isn't any problems, but I think there would be typical problems to what you would see on a normal mill and fill, where if you mill only partially the way down and there's existing joint sealant there, I think you would have to treat it in a very similar manner. So it's definitely something to be aware of and something to think about, but I would say it's similar to the hot mix asphalt. Are there any other questions? You got a couple minutes. All right. Well, thank you for everyone attending. As I mentioned, your PDH certificates will be emailed out to you no later than Friday, and the PDF and also the Pavinar will be posted on Friday. I will send out the email after I post it, and I'll try and remember to remind you that the website's been updated. But I do ask that you submit topics for next fall. We're going to be going starting September 4th every Tuesday, first Tuesday of the month for the fall semester, which will go through December. And I hope to see you all here next year. Thank you very much and have a wonderful day.